This is a report for Lab 2 of physics. The purpose of this lab is to model the electric and gravitational force on a tape with charge evenly distributed across the length of the tape. And the models and fundamental physics principles used in this lab include Coulomb's law and Newton's second law. And by modeling the charge on the tape as evenly distributed across its length, we see a more accurate representation of the net electric force on the top tape. The system and surroundings for this experiment is the same as in Lab 1, where the system in this experiment is tape B, the tape that is being floated, and the surroundings is everything else, including tape A, which is used to float tape B, and the Earth. A recap of the Lab 1 experiment: we put a base tape on a table and then got 2 new strips of tape. We stuck each new strip of tape onto a base tape and then quickly ripped each one up off the base tape, which charged each tape with the same sign. We then set the first tape dangling between 2 objects and held the second tape underneath the first tape. This allowed us to float the top tape upwards by the bottom tape. And this is a picture of the experiment done in Lab 1. This is the glow script code that we did in order to model the line charges, model the tape as a line charge. We're copy and pasted in the function for the electric field, and then on this slide you can see the electric field. We calculate the electric field at each particular point charge along the length of the tape and multiply it by the charge on each individual piece, and then we sum them all up in order to get the net electric force arrow. This is a picture of the computational model, and you can see on the top tape the electric field on each piece of the electric force on each piece of tape, and then the net electric force in comparison to the magnitude of the gravitational force. And errors for the experiments: manually measuring the distance between the 2 floating tapes is one potential source of error from experiment 1, as well as handling the tapes too much during the experiment, which could cause a decrease in the distance between the 2 tapes. And then from the second lab, potential sources of error could include using the values calculated from when the tapes were a point charge to now calculate the magnitude of the charge as a line. And some additional questions: what if we had modeled each of the tapes as a single point charge, and that would have provided a similar value as we found in Lab 1, and in this case the value from the line charge model for the net electric force was smaller than the value from the point charge model. And these estimates are different because the line charge model has points distributed over a greater distance than the point charge, and the value calculated from my line charge model is likely to be closer to the true value of the net electric force because it is a more accurate approximation of how the charge is truly distributed across the tape. And in conclusion, we modeled the total charge on a piece of tape where the charge of the tape was uniformly distributed along the length, and we saw that the magnitude of the net electric force was smaller than the magnitude of the electric force when we assumed that all tape was concentrated as a single point charge.